This session is OpenStack Cloud OpenStack Cloud at Yahoo scale, how to avoid disaster, and I'll hand it over to Anders.
Thank you. All right. My name's Anders Bateness, and I'm a paranoid. That's the official name for my group at Yahoo. I work in the information security group, which is an awesome place to work. Most of my time is spent with the platforms group, which has things like Hadoop, HBase, Storm, and OpenStack. So there are a lot of open source technologies that we have to deal with here at Yahoo. One of the things I love about my job is that my work has real impact on real people, and I really, really care about keeping our users' data safe so users can trust us. We operate at massive scale, which makes Yahoo a great place to do interesting work on large-scale deployments. When you deploy OpenStack, you are exposing new attack surfaces, which you need to protect in order to keep your system safe. OpenStack has changed how we deploy Yahoo to the world. And I'm going to share with you some of the things that we do to keep OpenStack secure. You may want to take the things I talked about into account when you're planning your own deployment or how to secure it. I'm going to start by talking about scalability. Now, what do you think of when I say scalability? What metrics do you use to measure scale? Let me tell you what I say when I mean when I say Yahoo scale. I measure by millions. 800 million monthly users. But the number of users online at any one time can fluctuate, so we get traffic spikes up to 10 times. You know, when you go to Yahoo, you want to find out what the news is. My wife and daughters are on a plane as we speak, 30,000 feet in the air. If I hear about a crash, I want to know about it now. And if I can't get the information I need because our servers are busy, I'm going to be incredibly unhappy about it. So, if you look at our web properties, such as mail, news, finance, you're talking millions of users per day. Those users need storage, which ranges it into the petabyte range. So, mail, 170 petabytes. That's equivalent to 170,000 1 terabyte drives. If you stack those drives one on top of each other, they will reach a mile into the sky. There's a massive amount of storage that's needed. We don't only need to scale, we need to grow. You know, mobile apps at Yahoo, they're experiencing huge growth. In order to support this, we're also growing developer talent. We have to hire more people to develop mobile applications. And what developers want when they come on board to Yahoo is more network, more computing, more storage. Now, in the old days, developers in the properties like finance, news, mail, they'd collect a bunch of hardware, and it was hard to get. So they'd hoard it because they might need it later. So what we need to do in order to break that type of cycle is to be able to have them create and log into a VM within minutes rather than days or weeks, which is what it takes to get new hardware. And that's where OpenStack comes in. OpenStack changes how Yahoo scales in a major way and changes our architecture also in a major way. We should also talk about how widely OpenStack is deployed at Yahoo. At Yahoo, we have deployed OpenStack worldwide in 4 continents with multiple clusters per data center. OpenStack allows us to use the same physical hardware for different properties such as sports or finance rather than having dedicated hardware for each property that sits idle until it's needed, until the next big event happens. In terms of scale, on the development side alone, over 13,000 VMs are used by developers in our corporate network. So you have developers, you have different types of data, user data, corporate data, systems. How do you go about securing all this? The answer is we slice and dice. So what are we slicing and dicing? The short answer is data. These are private clouds, and we control the data and the access to it. That's one benefit we have over public clouds. We slice off the production network from the corporate network. since we need to isolate user data from the corporate network. That means we need corporate OpenStack clusters separated from production OpenStack clusters. You don't want to have a single cluster with VMs getting mixed together with user data and developers combined. Now, since we're a private cloud, we can actually dice it finer. In production, our network is divided into security domains primarily based upon the type of data. Now, why do we do this? We do this because we don't want to give people who have access to one type of data access to other kinds of data they don't need to get to. We don't use IP tables because it doesn't really scale very well. We use VLANs and we enforce ACLs between VLANs. And we mirror that separation in our OpenStack clusters by deploying separate clouds or clusters in separate security domains. Yahoo always also controls who gets access to these VMs. Employees get security training, they're held accountable for their actions, and this is different than public clouds. Our production OpenStack networks, in terms of support, different types of things we support, we support the VMs using KVM, but we also support bare metal. For example, if you have a DNS server, it's getting hammered with requests, a VM's not really going to give it a lot of benefit. You just want to deploy it directly onto the bare metal and have it run away. We're also interested in Linux containers, which use control groups, namespaces, and so forth to provide a degree of isolation between application stack instances. However, containers by themselves are not able to provide the level of security that we can get with VMs. So that's kind of a work in progress. So this diagram provides a view of the different components in OpenStack and how they interact. Now, I have the best seat in the house. I can't make out all these individual elements. This side, look at that one. You don't want to cost a visit to the chiropractor. So you're probably thinking to yourself, how's the speaker going to explain all this? In 25 minutes? Explaining this slide alone would take over 42 minutes. Well, don't panic. I have 25 minutes. I'm not going to cover the basics of how the different components interact. Other people have done a good job of this, and the best place to go to learn more about the basics of how OpenStack works is openstack.org. The OpenStack organization has also published an excellent guide on securing OpenStack, which I recommend you read since there's a lot of useful information in there that I'm not going to go over. I'm going to focus on how we at Yahoo secure OpenStack and share that with you. So loneliness is a good thing. So why is loneliness a good thing? Loneliness is a good thing because you want the OpenStack infrastructure components to be isolated so that others cannot get to them. We don't want them to talk to them, poke them, use a zero-day exploit on them. In general, you want to limit access to those that need to access hosts and limit what applications and services are running on those hosts to what's needed. So in this section, I'm going to talk about the following thing. Who should the infrastructure nodes talk to? Hypervisors should listen to their parents. And by the way, when I use the term hypervisor, I mean compute node. Who should VMs talk to? So from my perspective, these are the major components in OpenStack. In the corporate network, we expose the Horizon dashboard to developers because when we need them to be able to spin up development VMs during their first day at Yahoo, we don't want them to wait more than a few minutes for the VM to be ready. Remember in the previous slide I mentioned we're hiring? This is what they use. I've seen users create a shell script to automatically reconnect to the VMs and keep a set of shells running using Screen so that they have persistent session on the VMs while they go move between buildings using their laptops. In terms of efficiency, we've seen up to 40 development VMs on a single host without issues, and I think we can probably go higher. The Horizon dashboard for these clusters, as well as all the VMs in the cluster, are exposed only to the corporate network, not to hosts in production, not to the outside world. And authentication is tied to our in-house single sign-on system. So there's a single source of truth for authenticating users, something you would want to do too. Production data is not allowed on the OpenStack clusters that developers use. We need to keep user data separate from corporate. Now, production is different. Production systems deal with user data, so we restrict how and who can manage VMs here. VMs tend to be created as part of an automated process, so automation needs to be able to talk to the nodes. Service engineers need to manage the cluster, so we limit who has accounts on the jump host to just those service engineers. And the infrastructure nodes are isolated from the rest of production and, of course, from the corporate network using VLANs in the case of level 2 networks. And jump hosts provide the only access. Apart from the obvious connections, we're a big company. We have a lot of systems, a lot of infrastructure for managing our hosts. So we need to be able to hook into that. For example, we need to talk to the DNS database for the host domain mappings to IP addresses. We need to talk to the operations database to say who owns what. And of course, all those connections need to be authenticated and authorized and restricted so that the infrastructure nodes can only do what they're allowed to do, what they need to do, and no more. So who should hypervisors talk to? Hypervisors should talk to their parents. If I could get my 15-year-old to behave like a hypervisor and talk only to me, I'd be a lot happier. And she would be a lot lonelier, so it's not realistic. Fortunately, at Yahoo, we can destroy the hypervisor's social life and limit who the hypervisors and Nova Compute talk to, and we do. So loneliness can be a good thing when we talk about OpenStack components. We created a separate, isolated level 2 VLAN for communication between the infrastructure nodes and the management interfaces on the compute nodes. But we don't allow the hypervisors to talk to each other. So you're probably asking yourselves, why don't we want the hypervisors to talk to each other? We don't want a compromised hypervisor to be able to talk to other hypervisors, so we don't allow any communication. That means that we don't allow VM migration directly between hypervisors. So you're probably asking a question now, no VM migration? Why is this not a big issue? How do you get VMs between hypervisors? Well, it's not a big issue because the applications we run are designed so that if an army of monkeys should randomly destroy VMs, we'll be able to keep running. And we can do this because we're a private cloud, and we have a lot of control over what is actually running inside the VMs. We shouldn't need to be able to migrate individual VMs to keep the system running, just as a straight policy or principle. If there's a compelling reason to do so, we can configure it so that VMs migrations happen using the infrastructure nodes as an intermediary. So again, hypervisors don't need to talk to each other. Now I'm going to talk about, so I've talked about infrastructure nodes and hypervisors. Now I'm going to talk about VMs. So who should the VMs talk to? At Yahoo, we've segmented our network according to what type of data the machine or VM handles. The infrastructure nodes and the hypervisors have their own separate security domains, and the VMs cannot talk to them. So you're probably asking yourself, what about the metadata service, where the VM connects to a hard-coded IP address to find out what its configuration is? Well, we don't use it. What we do is we've configured the compute node so that it supplies the metadata to its guest VMs using a special configuration drive that attaches to the VM when it boots. So no network connection to the infrastructure nodes is needed. And we've contributed a lot of code to CloudInit to enable this. So we're able to configure the VM as it comes up without needing to allow access to the infrastructure nodes where the metadata server is. So what do you think we're trying to protect against? If the VM is able to compromise the metadata service, it has access to the infrastructure nodes, which is a really bad thing. So my personal recommendation is don't use the metadata service. Or if you have to, if you can't use the special boot drive through CloudInit, and you have to go with the metadata service, find some way to mitigate the risk. So one of the interesting aspects of managing VMs is that the IP address gets reused when the VMs go away and another takes its place. We can't treat the VMs exactly like other hosts in the security domain, since VMs are a lot more ephemeral than the actual bare metal hosts, and the IP address gets recycled more often. You don't want the network to allow that VM the same level of access to the same set of connections that the old VM did. It has the same IP address, and its previous owner may have been granted access to additional systems. In order to do this, the way we do it at Yahoo is that VMs have two owners in our operations database. One is OpenStack and never changes, and the other is the temporary owner. When the temporary owner is removed, OpenStack cleans up and removes any special ACLs that were granted to that temporary owner. So the next time somebody spins up a VM using an IP address, it has a standard default set of access. The nature of VMs also changes how you connect to the console. In the old days, you'd have a terminal, you have a serial cable, you plug in the serial port, get into the console that way. Then you're starting to rack and stack host, and you have IPMI. Now with VMs, to get into the console, you have Spice. It's an API basically running on the hypervisor itself. However, we don't want to allow access from users to the hypervisors. So we have an issue there. The standard solution, everybody uses, is use Spice proxy to allow access to the VM console through the hypervisor, since hypervisors can stay isolated that way. We use certificates to initiate the connection. That's the top set of lines there, top half. But how do we actually authenticate the user? We need to authenticate the user in a way that's tied into the authoritative system of records. So how many of you have deployed or used some form of SSO? Raise your hands. All right, a few people out here. We have an SSO service inside Yahoo, and we use a cookie tied to our single sign-on system, so our single sign-on credentials to authenticate the user. And that's shown in the top half here. We're doing token and cookie credentials. So that's the way we do it. That's differently than the normal Spice authentication that Novo Console Auth validates both the cookie and that the user identified in the cookie is the same as the one in the token. And both cookie as well as token have a time to live, so it makes it harder to do replay attacks. So in Lord of the Rings, 19 rings were made with one ring to rule them all. The infrastructure nodes are that one ring. If Sauron gets control of that, we're in deep trouble. So one way to fix this would be to toss it into an active volcano, but management's not going to be very happy with that. So it comes back to restricting access. You need to restrict users that have shell accounts on infrastructure nodes to those that really need it. So look at those hosts, look at the accounts on there. Does everybody on that has accounts on there really need to have the account? You probably don't need all of them. So, cut out some that are not essential. You definitely should not be allowing users shell accounts on the infrastructure nodes in production. DevOps is great, but in this case, you really do want to restrict access to the minimum when you're talking about user data. Also, use SSL keys instead of passwords when SSHing into the box. Don't give people a chance to guess the password of those who actually have access to the infrastructure nodes themselves. Speaking of those responsible for infrastructure nodes, I recommend enhanced background checks for these people. Just like the ring bearer, you want the people who control the system to be reliable and to be able to resist the temptation of conducting an insider attack. If they have a history of losing all their money at the gaming tables, then you need to start worrying. So also, there are different groups of people that are responsible for maintaining the system. You have administrators that actually make changes to the configuration. You have administrators that may just be monitoring the hosts themselves to make sure they're still up. So, in the group that's monitoring, maybe there's a guy there named Boromir. And he's a good guy most of the time. But do you really need to give him access to everything? Don't tempt him. So each of the major components in OpenStack has policies associated with them to determine which users can do what. So one of these components is keystone. So who knows what a keystone is and where it came from? Well, in the Roman Empire, arches had keystones, and its function was to keep the arch from collapsing. If the arch collapses, the entire building might collapse. Here are you standing underneath it and looking up at it and the building that it supports. In OpenStack, the keystone component is a set of processes that function as a source of truth. Other modules rely upon that. So if you compromise keystone, you can end up granting Sauron access to everything. So different components in OpenStack have different policies associated with them. And the keystone policy is the one you need to be most concerned about. No user should need access to keystones, so we limit it to administrators only. This policy is stored in a JSON file, and I'm going to show you the policy that Yahoo uses. We want to authorize only the actions that need to be done. We have two levels of administrators. The ones responsible for maintaining the cluster have the highest level of access. And the SCs responsible for monitoring hosts in Yahoo have access to get information only. Now, we talked about keystone. Now I'm going to talk about preventing attackers from pretending to be us and spying on our secrets. What could you do if you can convince me you are part of the OpenStack infrastructure when you really aren't? If OpenStack believes you are who you say you are, you can tell other components to do things they shouldn't, and you can receive messages containing information you shouldn't receive. So one of the ways I recommend determining who to trust is to wrap your SSH keys in the host certificates. There are a lot of ways to get certificates onto a host or VM, and I could talk for an hour on this topic alone, but here's one possible way. You could run a SCEP client, simple certificate enrollment protocol, on the host and have it fetch the certificate from your PKI, your public key infrastructure. The question is, which PKI do you use? If you're a small operation, you can use public PKI. But if you're as large as Yahoo, it becomes really expensive. To give you an idea, it costs 7 figures to get 500,000 server cert units. At this scale, it becomes feasible to create your own PKI, buy the HSMs, the hardware security modules, protect the keys, and even set up special purpose intermediate CAs for functions such as issuing host certificates for OpenStack. It has the benefit of being under your control, so you can guarantee the SLA you need for your use case. Someone to watch over me. So, we need to watch over the system to prevent bad things from happening to our networks and hosts. Be able to see when that actually, if anybody's trying to do something. So hypervisors are most likely to be compromised after VMs and needs to be monitored for suspicious activity. So hypervisors should only be connecting to applications on the infrastructure nodes. So that would be one thing to look for when monitoring the network. Also, you want to make sure your version of your OS on your infrastructure nodes is hardened. We use a hardened version of Linux at Yahoo. It's also probably obvious to you, but make sure you're using the latest version of software. OpenStack software has a high rate of change. And when releases come out, they also include security patches. So, next generation networks. So, in this slide, I'm going to talk about the impact OpenStack has on different types of networks and how it changes the way OpenStack is deployed. We have to be able to scale our data center in ways that are not possible with traditional solutions. So, let's just go move on. This is like the old way of doing things. You have BGP at the top talking to the internet. You have OSPF. Spanning tree protocol down at the bottom with the rack switches talking to the core switches. So one of the things with spanning trees is it causes a problem at scale. And one of the problems you have is spanning tree meltdowns. One of the things that causes spanning tree meltdowns is a high rate of change in your network. OpenStack makes this problem worse since VMs are appearing and disappearing at a much higher rate than physical hosts, which causes spanning tree recalculations to happen more often. And of course, when you start doing this at scale, it starts looking like this, and it's an even bigger problem. So the way that we are trying to fix this is to go to level 3 networks. So what we're doing here is instead of the core switches, we basically have pizza boxes, and we're doing level 3 networking using IBGP. So we push the level 2 down into the rack switches. This means that the rack switch, we actually have them defined as the router for the default gateway to route out, and that way we're actually minimizing that type of problem. So if you're using level 2 only, it's easy to use VLAN to restrict traffic, but with this, we have to do things slightly differently. We don't have a lot of TCAM on the rack switches, so we actually can't put the infrastructure nodes on one of these rack switches. We actually end up having to put it back in a level 2 network using the old style of networking. Other way to fix it would be to create a special rack with more TCAM on it. So that's another possibility. So that's what we're doing at Yahoo. I've given you a overview of the administrative and technical controls at different layers of the system, from authentication and authorization down to the networking level, to secure OpenStack at Yahoo and to do it at scale. So I hope there's some bits you have learned here that you can use when securing your deployment. So thank you for your time. So I'd be happy to talk to anyone in the hallway who has questions. Thank you.